you guys remember these things? They're pretty cool. This is a balloon with a rubber band on it. I'll tell you why I have that in a second. Oh, if anybody's keeping track, my hair actually looks worse at this point. Still growing in, still got some work to do. The quarantine cut is in full effect right now. Anyway, welcome back. We are now in week number 5, I believe. Okay, so what does that mean? It means it's time to talk about Boyle's Law. And you're saying to yourself, Boyle's Law, that sounds stupid. And I'm going to tell you it's not. Boyle's Law is the relationship between pressure and volume. All right. Now, we're going to use some scientific words in here, like inversely proportional, but that's okay, because understanding the relationship between pressure and volume is something that you all understand, and you just have to keep it straight in your head. And it's not going to be too hard because that's the only law we're going to talk about this week. All right. So, what does it mean? Boyle's Law says that as pressure increases, volume decreases. That's it. So if I have this, right, and I apply pressure to it with my gigantic muscles, what happens to the volume? It gets smaller, right? And we all know that volume is the amount of space something takes up, and pressure has to do with the collisions, right? It's a force. So if we apply a force to the outside here, right, we're making it smaller. As we release, it goes back, right? So as we decrease volume or increase pressure, volume decreases. And I know you guys all know this. That's why I have this balloon, right? If I increase my pressure, my volume decreases. I'm pushing those air molecules closer together. And as I push them closer together, the number of collisions that those molecules have with the inside of this balloon increases. Okay? So it's not a foreign concept to you guys. It's just putting it and using the vocabulary that we're going to use. Okay? So again, Boyle's Law states that as volume decreases, pressure increases. And it also is the same vice versa, right? If volume increases, then pressure decreases. All right. So what that mean by that? If I were to take this balloon and I were to keep the same amount of air molecules in here and make it bigger, the pressure is going to decrease, right? Volume goes up, pressure goes down. Pressure goes up, volume goes down. And that's what an inverse relationship is. It means as one goes up, the other goes down, right? So another inverse relationship might be exercise, right? The number of minutes I exercise goes up, my body weight goes down, right? So that would be an inverse relationship. One goes up, the other goes down. And you're probably saying to yourself, what is he going to do with that beautiful looking chart behind him? Glad you asked. Because this paper, I'm not sure if you guys remember this, but about 2 weeks before we left school, maybe a week and a half, I gave you my quarantine prep packet. All right? Just in case we close schools, I said, take this packet home. It has a lot of good stuff in it. This is it. Now it's the time. We're going to start using this. Okay? I'll also post the stuff online so you can use that if you want to. But this is so you can print it out, whatever. But this is what we're doing today. It is Boyle's Law sample laboratory data. Okay, it's hot down here. Turn that heat down. All right, so here we go. So if you look at this, this is basically sample laboratory data. And what do I mean by that? It basically means like this is hypothetical data that you could get in the lab. So we have our trials, pressure measured in kPa, right? That's one of our units that we use, and then volume is measured in milliliters. So what we're looking at today, and let me see if I can move this a little bit. Okay, so what we're looking at today, and again, you have this, and I will post this worksheet in along with the video, is sample data. So let's look. So let's pick a volume, 40. Okay, and so if my volume doubles and goes from 40 to 80, and so when I'm doubling, I am multiplying by 2, right? So to go from 40 to 80, I multiply by 2. Whoop. All right. And so if I do that, what happens to my pressure? So if my volume doubles, what happens to my pressure? It gets cut in half. It goes from 100 to 50, and that is essentially dividing by 2. So it's the opposite, right? So my volume goes up, it doubles, my pressure goes down, it is cut in half, right? So that's what means it's directly proportional. So the amount that one goes up, that's how much the other goes down. And it's not like it goes up 12, it goes down 12. It's like it's scaled, right? So what would happen if my volume were to get cut in half? Let's say here, going from 10 to 20, okay? If my volume gets cut in half, or sorry, going from 20 to 10, cut in half means divided by 2. What happens to my pressure? If you say it gets multiplied by 2, you are correct, all right? So it is inversely proportional. One goes up, the other goes down. My volume goes down, my pressure goes up. My volume goes up, my pressure goes down. Now, if I had data here that said, let's say it gets multiplied by 3, right? So let's say I had 10 and I multiplied it by 3, that would give me a volume of 30 milliliters. Let's use our units. And then my volume would be 400, or my pressure would be 400. And to get that pressure, if I multiplied this by 3, I would do the opposite. So I would divide that by 3 and I'd get 133.33333. Okay, so that is the relationship between pressure and volume. It is inversely proportional. As one goes up, the other goes down. All right. I'm going to do another video where I talk about like doing the math part of this. So we got that to look forward to too.